Moving a business from physical servers to the cloud requires deliberate planning. You have to design a complete, production-ready architecture from scratch, mapping every single business need to a specific cloud service. If you're following along with our Google Developer Group Session 2 agenda, we are right here in the second segment. Our focus today is planning and configuring cloud solutions. We are going to translate that theoretical knowledge into a concrete deployment map for a fictional client, Symbol Superstore. Completing this architecture mapping is the exact preparation you need to pass the Associate Cloud Engineer Module 2 diagnostic questions. Let's look at Symbol Superstore's baseline infrastructure. They have two primary goals: migrating a legacy supply chain application to the cloud and completely upgrading their existing e-commerce web platform. This diagram outlines the 4 strict requirements for the new e-commerce application. It needs a container architecture for compute, a relational database backend, it must be globally available, and it requires analytical capabilities to inform marketing efforts. There is a built-in tension between these constraints. Specifically, needing a relational database while simultaneously maintaining global availability severely limits our infrastructure options because traditional relational databases are usually tied to a single location. Translating these raw business requirements into specific, scalable Google Cloud services is exactly what a successful cloud engineer does. Let's solve these constraints one by one. The legacy supply chain app likely relies on traditional virtual machines. However, the new e-commerce platform explicitly asks for a modern container architecture. Google Cloud offers Google Kubernetes Engine and Cloud Run. Cloud Run is a zero-ops platform that scales automatically. However, Symbol Superstore requires deep orchestration for its complex storefront. Serverless functions can't provide enough control, so we select GKE to manage our containerized applications. Choosing GKE means taking on more operational management compared to Cloud Run. We accept that trade-off to gain the architectural control necessary to run the storefront effectively. Next, we address the second and third requirements simultaneously. We need a relational backend that must be globally available. Standard regional database services, like Cloud SQL, cannot fulfill a global availability requirement without building complex and often fragile custom replication configurations across multiple regions. The definitive solution is Cloud Spanner, a fully managed relational database service providing consistency and horizontal scaling across the globe out of the box. With the live database settled, we shift focus to the final requirement: providing the marketing team with analytical capabilities based on historic sales data. We need to feed this historical data into BigQuery. BigQuery is a fully managed serverless enterprise data warehouse designed to handle highly performant queries across massive datasets. A key architectural rule is to split live operational data from heavy analytical querying. By moving historic data to BigQuery, we ensure complex marketing reports never slow down the live e-commerce checkout process running on Spanner. We have one final piece of the deployment: connecting the globally distributed customer base to this backend infrastructure. Regional load balancers are restricted to specific geographic areas, making them insufficient for Symbol Superstore's worldwide traffic demands. We require the external HTTPS load balancer. This service uses a single global IP address to intelligently route incoming user traffic streams to various regional backend GKE clusters based on the user's physical proximity. This single IP routing ensures high availability. If a specific region goes offline, the load balancer automatically reroutes traffic to the closest healthy cluster without the user ever noticing. The global load balancer acts as the front door. It hides the complex, multi-region backend infrastructure and provides a single, fast experience for every user. This diagram visually connects Symbol Superstore's business requirements to our finalized Google Cloud solutions. For compute, we selected Google Kubernetes Engine. For global relational data, Spanner. We configured external HTTPS load balancing for networking and BigQuery for analytics. Now that we have this architecture mapped out, you can use it to prepare for the ACE diagnostic questions. To master these tools, review the specific study topics in your course materials. Pay close attention to the modules on architecting with Google Compute Engine and Elastic Cloud Infrastructure, which cover virtual networks, scaling, and automation. You now possess the compute checklist, the database logic, and the study roadmap required to conquer Module 2.